Okay, so in today's video we have a simple indefinite integral e to the x multiplied by cosine of x dx. So it's pretty, like I said, it's actually pretty easy indefinite integral. This is actually a type of integral you'll see in Calculus II. Generally, you would solve this by performing integration by parts. But in today's video, here's the twist. I'm not actually going to be doing that. Otherwise, this video would be very easy to make. So let's get started. I'm going to show you how to actually integrate this without using integration by parts. So this is actually going to be very exciting. So one thing I want to state the definition is Euler's formula, which is defined to be e to the ix equals cosine of x plus I, the imaginary unit, I multiplied by sine of x. Now we know that when we take the real part of z, for some z is a complex number, x plus I times y, for x and y are some real numbers. When we take the real part of z, the complex number z, we get that the real is equal to x, and then the imaginary of z is equal to y. So therefore we can also apply by saying when we take the real of e to the ix and the imaginary of e to the ix, the real is equal to cosine of x and the imaginary is sine of x. So this means that we have cosine of x, we can actually just replace it with using the real of e to the ix. So when we have that, we have e to the x multiplied by the real of e to the ix. And then with using the property of reals, I can actually just move that outside the integral. So I'm taking the real of the entire integral, e to the x multiplied by e to the ix dx. And the base e, they share the same base, so we can actually use use our rules of exponents to combine it into one base. So this can be rewritten as the real of the integral of e to the and I actually can factor out x, so this is x multiplied by 1 plus I dx. And then I can actually just take a u sub, u equals x times 1 plus multiplied by 1 plus I, du is equal to 1 plus I, and then just divide by both sides so that we get du by itself. So then taking its integral, we actually get that it's the real is equal to 1 divided by 1 plus I multiplied by e to the x times 1 plus I. Okay. Cool, so far so good. And let's ignore the notation of the real for now. Let's just focus inside. So what I want to do now is rewrite this as e to the x multiplied by I, or 1 plus I divided by 1 plus I. And then there's an imaginary unit on the bottom, so what I can do is I can actually multiply by its complex conjugate. So the numerator and denominator will be multiplied by 1 minus I. So therefore, that way we get e to the x multiplied by 1 plus I, then that's being multiplied by 1 minus I, and performing FOIL, 1 times 1 is 1, 1 minus I is negative I, and then positive I, they cancel, and then we have I multiplied by negative I, which is negative I squared. That's actually equal to plus 1, so this is 2. So I'm going to rewrite this again, and divide by 2. Okay. And now what I want to do is I actually would like to distribute the e to the x. I can also rewrite here in another sense. I can actually rewrite this as e to the x times e to the ix. Then that's being multiplied by 1 minus I. So what I'm going to do is I'm actually going to distribute the e to the ix into the 1 minus I and leave the e to the x outside of it. So when we do that, we get e to the x, and then that's being distributed from here. This is e to the ix, then minus I times e to the ix, and then that's being divided by 2. And then we can actually replace e to the ix with our Euler's formula. So in other words, this is e to the x multiplied by cosine of x plus I sine of x, then minus I, and then that distributes the same as before, so cosine of x plus I sine of x, and that's divided by 2. And then we can further simplify this out. So we get e to the x, then cosine of x, then plus I sine of x, and then I'm gonna distribute the negative I into the cosine x with our Euler's formula. So this is minus I cosine of x, then negative I multiplied by positive I, that's negative I squared, that's also equal to 1, positive 1. So plus sine of x, and then over 2. So we have our simplified expression. So now the last part is we have to take the real of our simplified expression. E to the x cosine of x plus I sine of x minus I cosine of x, then plus sine of x, then divided by 2. And it's actually pretty easy to see that since there's I terms, those are its imaginary part, but we're being asked to find the real part. So the real part is basically e to the x multiplied by cosine of x, and then then plus sine of x divided by 2. And that's our integral, our indefinite integral. Since this is indefinite, so you put a plus c for constant since we don't have our bounds. So there we go. And you can actually see that when we do integration by parts, we get the same answer as this. So it comes out pretty nice. It's pretty sweet.